Welcome back to part 2 of week 2 of Math 277 recap. In this video, we will be going through a couple more practice problems relating to intersection of curves, parametrization of equations, as well as do a couple more rocket problems. So in this first question, this is the intersection of two given surfaces. So we want to see, we want to find the parametric representation. So we want to see how we can relate these two equations together. So we have 4x squared plus xy equals 16. And our second equation is 2x plus 3y plus 2z equals 1. Okay, so we're going to work with this equation first. This equation only has two variables, and taking a look at it, we can rearrange to get it to equal an ellipse. So then this is x squared over 4 plus y squared over 16 equals 1. So this is a circle. So what we're going to do with that circle, let's put it into our equation. So then we don't have an h or a k value, so this is just going to be 2 cos t, I direction, because we're taking our radius for our first term, and since this is represented as a squared and we just want a, then we'd have to square root that 4, which gives us 2. And then this is plus our y value, so there's no k value. So then this will just be square root of 16, which is 4 sine t in our j direction. If we separate out our terms, we get x is equal to 2 cos t. And if we use y is equal to 4 sine t. So what we're going to do now, we're going to plug into equation 2, second equation. So we're going to plug these values up into our blue equation to find z. So let's isolate for our z. So let's do 1 minus 2x minus 3y equals 2z. Then divided by 2 equals z. So this is 1 minus 2. Let's plug in x, which is 2 cos. This is minus 3, and we're going to plug in our y. So that's 4 sine t, and that is equal to our z over 2. That's 1 minus 4 cos t minus 12 sine t over 2. And to simplify it, let's do this. Minus 6 sine t is our z term. So if we write out the full equation, this becomes, so we have 2 cos t in our I direction plus 4 sine t, this is our y variable. And then we just found our z variable, so we're going to plug that in. So this is half minus 2 cos t minus 6 sine t in our k direction. In part 2 of question 2, we have a similar scenario where we have we don't have all three of our variables within our surfaces. So that means we can work with one and then use it to find the other. So we'll work with the first equation to find what x is, and then we're going to plug that x into our second equation to find our z. So let's do that. X squared plus y squared equals 4. And when we parametrize this, so this is x squared plus y squared over 4 equal to 1. So this is a circle. So this looks like there's no h or k value. So it's going to be 2 cos t plus 2 sine t, j direction. And that gives x equals to 2 cos t, y equals to 2 sine t. And then let's plug this value in for our second equation, which is given by z equals x plus 1 to find what z is. So z is equal to, so let's plug in that x value, which is 2 cos t plus 1. So our final equation is rt equals cos t I plus 2 sine t j plus 2 cos t plus 1 in our k direction. Okay, next question. I'm going to zoom out a bit so I can write both of them. Okay, so now we have a little something different. So we have equations. We have one with 2 variables and we have one with 3 variables. So in this case, this would be a good idea to equate some of our values. So let's start with our first equation. And then our second equation, which is 2y squared plus z equals 1. So I would recommend isolating our z value. It's going to be easiest. So if we do that, that's x squared minus y squared minus 3 equals z. And this next one here is z equals 1 minus 2y squared. I feel like we did this question already. Okay, so we did do this question. This is the one that was in the notes. So I'm going to skip this one for now. Let's instead move on to question 4. Feel free to try this one on your own, just to make sure you can understand it as well. Okay, so let's do our 4th question. So this one gives us a hint to use t in place as negative z. So let's see what they mean by that. Where t is equal to negative z. Okay, so in that case, we would start with, okay, hold on. I would start with this equation. So let's do x plus y plus 1. Oh, yz. Oh. Okay, sorry. I'll try again. Let's plug in negative t for each of our z components. And then we can isolate for some values. So that's 2 minus negative t squared equals, plus x equals y. And then let's make this one equal to y as well. Actually, no, it'd be easier to make this equal to x. Trial and error is going to be a big theme of these kinds of questions. Okay, I'm going to start with this one instead. Let's do x is equal to negative yz minus 1. And then let's plug in for our t. So then this is going to be positive. This is going to be positive t and y minus 1. And then for our red equation, we isolate for x. This is z squared plus y minus 2 equals x. That's negative t squared plus y minus 2 equals x. X is equal to t squared plus y minus 2. So now let's equate these two together so we can get rid of some variables. So then that's going to be t squared plus y minus 2 equals ty minus 1. And we can isolate for t. So let's do t squared minus ty plus y, and let's move that 2 to the other side, 1. Let's factor this out. Sorry, let's move this t value over. So this is t squared minus 1 equals ty minus y. T squared minus 1. Then let's factor out that y. So that's t minus 1. Okay, t squared minus 1 divided by t minus 1. Oh, okay, it's equal to y. Sorry, I'm losing my marbles on this one. And this is a difference of squares. And this is equal to y. Cancel out those, which is equal to t plus 1. Okay, that one was kind of gross, I must admit. Okay, so now that we've done that, let's plug y to find x. So we're going to take this value now and find x with it. So let's use our second equation because it looks easier than our y value, which is t plus 1 minus 1 is equal to t squared plus t minus 1, and that is our x value. Okay, so when we put it all together, okay, this is looking better. I'm feeling better about this one now. So then we have our x, which we just found, plus t minus 1 I, plus our y value, which is over here. And from the beginning, we said negative z is equal to t, so that means z is equal to negative t. So plus negative t, k. So that one had a lot of rearranging to do. So yeah, basically plug in whatever your new value is. So plug new variable. So plug new variable, equate equations, solve for one variable, and then plug for remaining. Okay, moving on to question 3. Find the Cartesian equation of the plane curve given parametrically by x and y. So how I would start by solving this So let's start with our x first. So this is -2 plus 3 cos I, and plus our y component in our j direction. If we were to write this out, we would see that this is, so our coefficient for cos and sine is the same, so therefore it's a circle with center -2 and 4. So this is three, actually no, equals 1. So then we'll do our x plus 2 squared over 9, because we want to take our radius squared, and this is plus y minus 4 squared over 9. All right, and that's all our question wants us to do. This is our answer. You can also express it with the 9 on the other side if you wanted to do that instead. Okay, question 4. Find the Cartesian equation of the plane curve given by this equation here. So let's do the same thing. Let's separate our x. So x is equal to 2 plus 7 cos t. Then our y is equal to -1 plus 2 sine t. So this is already in our parametric equation, so we just need to identify what we're looking at. So our coefficient for cos and sine are different, so then therefore this is an ellipse. And this is simple enough. We have our h and k values, so then our answer is going to be, so x minus 2 squared over 7 squared, which is 49, and this is going to be plus y plus 1 over 2 squared, which is 4, is equal to 1. A couple quick questions right off the bat. So this is like question 3. So if we were to write this out, it's 2 cos t in our I direction, and then this would be plus 4 sinh squared t. So now that we got this squared, what are we supposed to do? Okay, so let's find out. Actually, I'm going to skip this equation. I may or may not come back to it later. Okay. So find a parametrization of the intersection of two given curves. So this is what we did in question 2. So we have our first equation in red. Then we'll do our second equation in blue. And let's make this equal to z. So then we'll do -8 minus 2x plus 8y equals z. And let's make these equal to each other. So then this is x squared plus y squared equals -8 minus 2x plus 8y. Let's move some stuff around. So that's 3x squared plus y squared minus 8y and then plus 2x equals negative 8. And let's group our x and y terms so that they're closer together. And we're going to need to complete the square for this. Okay, so to complete the square, sorry, I made a mistake. This is meant to just be x squared. So now we can complete the square. So to do that, we're going to take x squared plus 2x. We're going to take half of 2x, and we're going to add it. So that's 1. Do same thing with our other side. So half of our middle term is negative 4. So minus 4 equals negative 8. And we're going to add the square roots of our added value there. So that's plus 1 squared and plus negative 4 squared. So we can factor these out. This is going to give x plus 1 squared plus y minus 4 squared equals negative 8 plus 1 plus 16. So negative 8 plus 1 plus 16. And that's going to equal 9. And now this looks like something we can work with. So if we divide our 9 to either side, we see that this is a circle. So if we parametrize for this surface, this will give us our t equals, so we have negative 1 for h value plus 3 cos t, and this is plus 4 is our k value, plus 3 sine t j. So that's the answer to part 1 of this question, which introduced completing the square once again. I'm going to skip the part B of this question and move on. Okay, so question 7. A ball of ice with mass 100 grams at time 0 loses mass at a steady rate of 1 grams per second. So it's a negative value since it's losing. And its initial velocity is I plus 2j, subject to a constant force of 3I. So what is velocity of the ball after 1 minute? Okay, so this is a bit of a longer question, so I will revisit this, maybe. Instead, let's focus on one that we've already seen before. Let's look at another rocket question. So let's use question 8. Actually, no, question 8 was what we did in the notes. Okay, let's use this one. So rocket has 25,000 initial mass, which includes our fuel. And during the burning process, gases are ejected at 1,000 kilograms per second at a constant velocity of 400 meters per second. So we want to find its velocity at 15, 20, and 30 seconds. So something we can find first is when fuel runs out. So this is going to be given by a time, and this will be given by our mass of fuel. Over our rate of ejection. This is equal to 20,000 over 1,000, which is equal to 20. So at 20 seconds, it'll run out. So we can already answer what 30 is going to be. So 30-second speed is equal to 20-second speed. Because after that point, when there's no more fuel, our velocity will be constant. Okay, so let's find at 15. So we're using our same equation. So V at 15 is equal to VE ln M. And this is M minus alpha T. If we plug in our values, we have 400 ln 25,000. And this is 25,000 minus 1,000 times 15. So this gives us so let's put 15, store that as a variable. That's 400 ln divided by 2, 5,000 minus. And this gives us 366.516 meters per second. If we plug in at 20, we have 643.775 meters per second. And like we said before, at 30 seconds, there's going to be no more fuel left. So that means our velocity is going to be the same as we left it in 20 seconds, because now it's moving at a constant rate. Okay, so that brings us to the end. I've decided not to revisit those questions and let you guys try them on your own. So that would be question 7 and question 5, and see if you can get the right answer, knowing what you already know about the topics from this week. I hope you guys enjoyed, and I will see you in the next one.